Alright, so for electron configuration, the main key that you need to know is this SPDF. And using the periodic table to do electron configuration is super helpful. Here's the F block, here's the S block. Don't forget helium is also part of S. Here's the P block, and here's the D block. My period 5 and I came up with a really awesome analogy. Silly dogs poop on the floor. You can remember it however you can remember it. You can put it on your index card, I don't care, but silly dogs do poop on the floor. So if I am doing electron configuration, I have a couple things I have to list. I do have to list the energy level, or the row, that it's in. So if I'm looking at hydrogen, for example, hydrogen is in the first row, so I draw a big 1. It's in S block, so I draw an S. And then it's the first one in S block. It has 1 electron, so I draw a little 1 up here. This big one tells me energy level. The S tells me the block it's in, and this little one tells me the number of electrons. So for example, helium over here is still in the first row, so it's still 1 for its energy level. It's still in S block, however, it's 2 electrons, because helium has 2 electrons, so it's 1s2. Say I make it a little bit more complicated, and I pick fluorine, which is right here. To do fluorine, I have to start all the way at hydrogen and go through every single electron. Now fluorine's atomic number is 9, which means neutral fluorine will have 9 electrons. So I like to write the number of electrons underneath. I start at the first row, 1. The first block I hit is S, and there's 2 electrons in that 1s block, and I know in my first energy level I can only fit 2 electrons. So then I get down to where lithium is, and I'm in my second row, and I'm in the S block. And lithium and beryllium are the 2 elements in 2s, and I know in S I can only fit 2 electrons, so that's 2s2. Then I keep going. I'm still in my second row, but now I hit P block, and I have to go over 5 to get to fluorine, so it's 2p5. Now a cheap trick to figure out if I did this right is to count up all the electrons. 2 plus 2 plus 5 is 9, and I can check fluorine has 9 electrons, so I did this correctly. Now I do have a shortcut, and it's called noble gas notation. Instead of putting in this whole thing for fluorine, not a big deal, but for some other elements it might be. I pick the noble gas that has the atomic number less than my element. So fluorine has an atomic number of 9. If I look at all my noble gases, this right-hand column of the periodic table, neon's the closest, but it has 10. And I can't go past fluorine. I have to pick one before. So I pick helium, number 2. So helium I put in brackets. That's like saying, okay, go to helium, and then what do I do? After helium, I go to 2s2, 2p5. And obviously, this is a lot easier when you're dealing with an element that's further down in the periodic table. Things to note, the D block goes back a level. So it goes from 4s to 3d, 5s to 4d, 6s to 5d, and 7s to 6d. The F block doubles back. So you go from 6s to 4f and then to 5d, 7s to 5f and then to 6d. So just keep in mind that it doesn't just go 6s, 6f, 6d, 6s, 2 back to 4f, and then 1 back to 5d. The P follows the same energy levels as S, so after my 5d, I'd go back to 6p. Hopefully you have some kind of labeled periodic table that will help you remember this. I wouldn't be too worried about the F, I would worry about the D's. If I want to draw an orbital box diagram, there's a couple things I need to remember. I have my 4 kinds of orbitals, S, P, D, and F. S has 1 box, and each box fits 2 electrons, which is why I can fit 2 electrons in S. On my periodic table, the S block is 2 columns wide. P is 3 boxes. It fits 6 electrons, and that's why in the periodic table, P block is 6 elements wide. D, 5 boxes. 10 electrons. And if you look at the periodic table, D block has 10 elements across. F is 7 boxes, 14 electrons, and same thing with the periodic table. If you look, 1, 3, 5, 7, it counts up from the odd numbers. So if I were to draw the orbital box notation for, say, oxygen, I know I always start at 1s. Because it's S, I draw 1 box. I can fit 2 electrons in here, 1, 2, spin up and spin down because they do repel. Then I get to 2s, the next part of the periodic table. It's S, 1 box. Even though there's 2, I still draw 1 box. The 2 just tells me that my s orbital, which is the shape of a sphere, is slightly larger. After 2s, I get to 2p. P tells me to draw 3 boxes, but because they're all 2p boxes, I draw them connected. Now here's where Hund's rule comes into play. Hund says I